Hey there, welcome to another video where we dive deep into a fascinating problem related to C++ programming. Today's problem revolves around understanding how to count the number of members in a class using a clever method involving const_expr and requires expressions. The problem we're tackling here is quite intriguing, especially when it comes to deciphering the intricate logic behind the requires clauses in the code snippet provided. Now, let's get into the solution to this problem. The key to understanding the requires clauses lies in the way they handle nested braces, particularly when dealing with aggregate initialization. By utilizing a special template structure called UniversalType, we can mimic any type within the aggregate initialization process. For instance, when we look at the struct x with two member variables, we notice that the code behaves differently based on the number of UniversalType instances supplied, allowing us to count the members effectively. Moving on to a more complex scenario, let's consider the struct y, which includes an array in a single member variable. By progressively adding UniversalType instances during initialization, we can observe how the code responds differently based on the presence of these nested braces. This subtle manipulation of braces enables the accurate counting of members within a class, even when dealing with arrays and multiple member variables simultaneously. Now, let's explore a specific case involving list initialization, where an empty aggregate poses a unique challenge. In this context, we observe how an empty aggregate initialized with UniversalType triggers a compilation error due to the excessive number of initializers. This highlights the importance of handling empty aggregates differently to ensure the correct counting of members despite such edge cases. Continuing with our exploration, let's delve into a more intricate example involving different struct types, such as A, B, C, and E. Through static assertions and aggregate checks, we uncover notable discrepancies in the counting mechanism, particularly when dealing with nested aggregates and complex member structures. These insights shed light on the nuances of the counting algorithm and underscore the need for refined logic to handle diverse class definitions effectively. In conclusion, we've delved into a fascinating problem in C++ programming, unraveling the intricacies of counting members in a class using const_expr and requires expressions. By understanding the role of nested braces and aggregate initialization, we've gained valuable insights into how the code navigates complex class structures to accurately determine the number of members. I hope you found this exploration insightful and engaging. Remember to subscribe, like this video, and share your thoughts in the comments below. Until next time, happy coding!